Bismillah ar-Rahman ar-Rahim. Students, this is a topic. We have a circles topic. So concentrate. Circles topic. So we have some properties. One by one, I'll discuss properties. Get ready. Property number one, which I will discuss with you, is here. Number one, whenever we have a circle and whenever we have a radius. Okay. And if I have a tangent. So what is a tangent definition? A line touch and go is called radius. Then tangent. So make sure one thing, whenever there is a, I mean to say, there's a tangent, I'm writing the word tangent, and this is a radius. An angle between radius and tangent always 90 degree. How to write it? Angle between radius and tangent is right angle or 90 degree, same thing. This is the reason. So sometimes he asks a reason for you, so reason is here. Okay, he will ask you sometimes, some not. Okay, same time I show you examples. So let's have a look here, some examples. So I'll show you examples same time, then you can realize the questions, the idea. The tangent, let me show tangents. In this, no idea of tangent, 1 minute please. Yeah, here. In this question, we have a tangent. You can see this one idea. So in this question, we have a tangent. This is a tangent, this line is tangent. And this angle from here till here is 90 degree. So I believe you got a point. What is tangent definition? Angle between tangent and radius is 90 degree. So first property, I believe you understood. Even here,
Property.
this is a tangent and this is a radius. So from this line till this line is called 90 degree. I believe you got the point. So first property is very clear now. First property you learn, and that first property learn, look at here, in this diagram. Is it tangent? Yes. Touching the circle. Is it radius? Yes. So angle between radius and tangent 90. So this is 90 degree for sure. This is 90 degree from here till this line. And from
Sir,
here
it's
till
always
this
90.
line. Again?
Sir, it's always 90.
Yes, my son, I've given you 3, 4 examples. You don't believe me still? Till Yom Al Qiyamah. Okay? I given many examples.
Yes, sir.
Not one, but still you're saying always, sir? But no problem, because you don't believe me this as it is. So even I showed here, look at here. So I think this is an example we have. This example we have, wait a minute. And I believe you'll understand. Look, in this question, he asking us what? He asking us that find out the x, find out x. And I know this is a radius, this is a tangent. It means from this to this is angle is 90 degree. What is this angle? Single x. What is this angle? 4x. So it means x plus 4x equals to 90. In this way, we can find out x so easily. So 90 by 5, you can get the answer easily. For 5 ones are 5. So 5 eights are 40. I think idea is clear. So first property is very clear.
18.
Property number 1 is clear. Property number 1 is clear. I come back in a same point again. So I believe property number 1 is clear to you. Now let's go property number 2. Property number 2 we have, if we talk about property number 2. So second property, most important property we want to teach you is, wait a minute. Okay, I'll take second property, which is most important, one of the, so it means this is angle at center. So O as a center, and this is joining here. Wait a minute. I'll make it again. And joining from here to here. This is A and there's a B. And this is called center angle. So let's say center angle is what at here is, let's say it is a 80 degree. Just imagine. So this is called minor arc. Repeat my words. Minor. Minor is called smaller. We have two ways to go from A to B. One small path and one long path. So smaller path is called minor arc. Longer path is called major arc. So if you have a C on major arc, I repeat my words. C must be on major arc anywhere. It can be here, 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 anywhere. But it cannot be here. Make sure it is not be here. So on a major arc anywhere. And if you join the line from C point to join A, and joining C from AC to B, so make sure the angle here will be half of it. Half. I repeat, how to read this angle is called angle at circumference. Why it's called circumference? Because this is circumference. This full is called circumference. So this is called angle at circumference. I'm writing statement. Reason. What's the reason for it? Angle at center. Angle at center. Angle at center is twice than angle at circumference. Angle at circumference. Okay. Now, if you don't believe me, what is it true or not? So let's have some examples. If there's a 40, double here 80. If here 80, half is 40. So let's talk some examples. So let's see some examples. So first example, I'll show you. There are many examples available for this situation actually. For example, here in this idea, I'm going to show you. Look at here. I given a three ideas here. If this is x, this 2x, half of 2x is single x here, or reverse. If you have x here, double become 2x, so 2x is here. And for your knowledge, this is called angle at circumference. This is called angle at center. So I think this idea is clear, but I think you're not understanding this way, so I will give you some examples, some more examples. Have a look. This is angle at center, very clear and very final, 160, 146. And Q and S, we have 2 points. And this is called shorter path, and this is called longer path. Longer path is called major arc. This is called minor arc. So any point on the major arc, I mean to say here, 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 anywhere, anywhere, anywhere. And you join that point with a Q and S. So this angle is called angle at circumference. And this angle is 146. And notice this one half.
73.
146 divided by 2. 2 sevens are 2 threes are. So Mabruk 73. So I think you understood the definition some extent. Let's move on next. So some more examples. I will not leave it here. I will show you more examples. For example, this idea is again, we have A fix and C here. This is called minor arc. This is called major arc. So on a major arc, we have a 1 point which is joining with the A and joining with the C. And this angle is 110. If someone asks what is X, you say, sir, not a hard job. 110 divided by 2, you got a 55. So this is a 55. Alhamdulillah, Rabbil Alameen. Very, very clear. Now reverse. In this question, reverse. Reverse means angular circumference, we know it. And we want to find angular center. So X is equal to what? Double. 52 into 2. 56 into 2. 12 at 112. So this is coming 112. So I think so very clear. This angle 56 given, and this is a double. And that is why you can see this. I got this answer 112. So I think second property also clear to you, and you're not getting any big issue. So second property, I think you understood well. Let me check more examples. Yeah, here, if this is a 140 angle at center, angle at center, okay, and this is A fix and this is a B fix. How I know? How I know? Look at there. This angle starting from A and this angle starting from B. And A to B is called minor arc, leave it. And A to this is called major arc. But make sure what's the criteria, that point should meet A and should meet B. So these two meeting points. So this angle between these two lines is a half of it. So this is a 140 divided by 2. I got 70. And I believe all of you understanding this point very. So third property of circle is we have here, for example, I give you an idea. So that is also one of the most important properties. For example, A is fixed here and B is fixed here. Now, no, here center is concerned, but this property, no center is concerned. Let's say C is available here, okay? And if I meet, for example, take a scale and join them. I'm joining with the blue line, as you can understand, this is join. Same way, join with the B. Okay, joined. Now this angle is assume any angle. Let's say this angle is 40 degree. Okay, and this is called arc or segment. Same thing. Arc better. I think better words. So
Minor.
arc. Yeah, you minor arc. Correct. And this arc is fixed. And now I'm meeting another point. For example, I'm meeting at this point D. But A and B are fixed. A and D are fixed. So look at here. A and B is fixed. Sorry, I mean to say. Wait a minute. Okay, I'm meeting from here to there. Okay, and then I join with a B also. Okay, now this angle is 100% same angle which I got there. Reason, because this arc is same, and in front of this arc, if I go from this arc and go in this angle, and go from this arc in this angle, they are equals. And it's called, what is the reason behind, what is the reason, how to write a reason. Reason I'm writing here, reason, angle by same arc, angles, subtended word you can use, subtended or makes, no problem. Subtended, subtended by angles, subtended by a same arc, by a same arc, or sometimes you word segment, no problem. Same are equal, are equal. If you don't believe me, I'll move on and I'll give you more some examples. Get ready. I think I will give you not one example, many examples. Okay. And first of all, have a look here, this example. So inshallah, I believe you'll understand. For example, you fix, this arc is fixed. This fix, R is fixed, Q is fixed. I join from here and I meet at this point. And this angle is 100% 21. Again, I start from, it means this angle and this angle 100% same. Again, I start from here, meet at this point. So this angle X is also 21. So we can say directly that X is 21. So let's move on some more example. I will not finish here. Example here. Now, example. Okay, I think this is a little bit hard example to understand. This example is good to understand. We can apply many times. Look at here. If this DC arc is same, have a look here. DC arc C is fixed, D is fixed, and I move on and meet on a circle edge. This is 42. And I meet on circle edge. This is angle at here. So this angle is also 42. So I mean to say, you see this 42, this is also 42. This one property. I can apply one more property. You know where I can show you. Wait a minute, I show you. Have a look. This time I make it DA as an arc length. DA as an arc length. Get ready. DA arc length. So angle here and angle here. And I believe you're understanding, they are equals to each other. This is 28, this is also 28. I'm not leaving it here. Have more examples. In this diagram, there are many angles, I think same. I try to help you here. Have a look here. Have a look. Same property we can apply many times. For example, this is a BC arc, and this joining is a here, and the joining is here. You can't say join that one. No, no. Why, sir? Reason. Because look at it, I can give you a proper idea. There's U is 38, and I give you why, sir. Why I make this kind of lines and arcs. Have a look. I give a proper idea. This BC arc. Okay. So line joining from B and C. Make sure line joining must from B and C. So look, this line, red color line starting from B, ending at D. Starting from C, ending at D. So this is called angle U. Okay. Now same story. I can start from C ending at A. Start from B ending at this one. So this angle is the same U. That means they are equals to each other. So I think you got some idea now what I'm explaining up till now. And let's go for some more examples. One more example at least. Then inshallah, I believe we can start some other property even. No problem. Okay, have a look here. Then inshallah with some practice will do. Otherwise you will not improve. Okay. And I think this is another good example we have. You know, this total A to D is one arc, A to D, A to D. Make sure. So starting from here, I meet, look, A to B I meet, and D to D to B meet. So come back. So this angle is this one. As okay, and again, A to C I join and D to C I join. It means I talk about this angle. So their angles are equals to each other. So both are angles each other. So fourth property is there. If I have a 4 point on a circle, this anywhere A, B, C, D. These points can be anywhere, but on the circle must be. Not inside circle, make sure, wrong. Not even outside circle, wrong. Must be on the circle. And if you join all the 4 points like this, A to B, B to C, C to D, and D to A, it has special name. You know what special name it has? And I gave a reason also. What is the reason behind it? Okay. Fourth property, the reason. What is the reason for it? I just tell you, this is called special name is called cyclic quadrilateral. Okay. And reason is that opposite angles in cyclic quadrilateral, cyclic quadrilateral. Wait a minute, explain what is a quadrilateral means. So cyclic quadrilateral are supplementary, supplementary. Now you don't know what supplementary means. Example, if I add 110 plus 70, it give us 180. So these two angles are called 110, 70 are called supplementary because add the 180 degree. For example, 180. If you add them, you get 180 degrees. So they are supplementary angles. 120 plus 60. They also called supplementary angles. So it means whenever you add two angles and give us 180 degree, those angles are called supplementary angles. And hold on. What is called cyclic quad? What does quad stand for? Quad stand for four. So four side figure. Look at here. A, B, C, D, four side figure. Not five, not three, not two. Four side figure. Quadrilateral is called four side figure. Square is also called quadrilateral. You can say. And for your knowledge, kite is also called quadrilateral kite. So we quadrilateral are many shapes, but cyclic quadrilateral means as such a quadrilateral, such a four-side figure, all point must be on the circle edge, not inside, not outside. And what is the property says opposite angles are supplementary. It means if this is 100 angle, so this 100% 80. Why, sir? If you can add them, it give you 180 degree. And let's say this is, for example, I give an idea. Let's say this is I just wait a minute. I take rough. Okay, rough means I take it 95 or let's say 120. Then what is this could be confirm 60. Why? If you add them, give you 180. So what is the reason behind? Now I can prove it. Let's move on examples. So cyclic quadrilateral. Okay. So very interesting. In this diagram, we have a cyclic quadrilateral. I'm going to show you. Wait a minute. Where is cyclic quadrilateral? There's very interesting diagram here. Look at here. I can prove it. A, B, D, E, A. Okay, it is cyclic quad. Why, sir? One side, second side, third side, four side, and this is 27. And there's an opposite angles. This one, there's a one. How much this? 180 minus 27. If we subtract, I get 3 out of 7. I got a 50, 153. So it's a 153. Why, sir? Because if you add them, give you 180. Look at how I'm showing you 153 plus 27. If you add, give you 180 degrees. So it means if you know one angle, how to find second one? So 180 minus the first one. So it give you cyclic quadrilateral concept. Come back. Some more examples.
Sir, where was quadrilateral over there?
Dear my son, Quad is quadrilateral means four-side figure. Let's count. 1, 2, 3, 4. You see? I repeat. 1, 2, 3, 4. Can you see four-side figure?
Yes.
Okay, come back. So this 1, 2, 3, 4 is quadrilateral, cyclic. Special name cyclic quadrilateral. If this is a 58, what is this angle? So you can say this is 180 minus 58. So we can find it easily. Some more ideas. Okay, this is not cyclic quadrilateral. Hold on. Look at here. Listen to me. So 1, 2, 3, 4. This is not cyclic quadrilateral. Why, sir? Because this point not on a circle edge. This is not a circle edge. So that is why make sure all point 4 point must be on circle edge. So have a look here. This is example again a cyclic quadrilateral. How come, sir? Look, 1, 2, 3, 4, and all 4 point on circle edge. If this is 108, this is called opposite angle. How to get this one? 180 minus 108. And I got 72. And I believe all of you understanding. Alhamdulillah. Rabbil Alameen. And let's move on next. This is a property number 5. And what is the property number 5? Is in this property number 5 when diameter is confirmed. And diameter means a line which go through the center of circle and meet the edge of circles. This is called diameter. Let's A and B is called diameter. Okay, the center of circle lies on it. So diameter is this mentioned here. This means this kind of property, diameter is compulsory. Any point on the edge, anywhere on the edge, up and down, anywhere. For example, C is point is here, okay? And if you join C with A and C with the B, make sure the angle at C is always 90 degree, no other angle, always 90 degree. So what is the reason behind it? Reason, and I'm writing here. Angle in a semicircle. You can ask me, sir, why semicircle, sir? Let me tell you what's the reason. Whenever you draw a diameter, it makes a circle half down, half up. So it means two semicircles we have. Angle in a semicircle is right angle. Sorry, angle semicircle is always yeah. You can say angle in a semicircle is yeah, you can say correct, right angle. Right angle. Right angle means 90 degree. Right angle means 90 degree. I want to show some examples. I will not leave it here. Let's start. So I will search those questions in which diameter is mentioned. Diameter is mentioned. And for example, this question is also we have. Have a look here. Have a look here. Have a look. Have a look. So this is a diameter. This GI is a diameter. Which point joining with the diameters, corners? This is not joining corner diameters. Wrong. This is not joining. This J is joining. How come? J join with the K and J join with I. And angle at this place, angle from here till here is 100% 90 degree. This is not one example. I'll go show you more examples. Come back. But make sure diameters must be there. Diameter must be there. Yeah, this is another a good question. Very good question we have to understand. Have a look here, all of you. So where is diameter? Diameter is AOE. There's a diameter, done. Okay. Which point join the end of diameters? This F is joining one, but not joining second. So we can't say here 90 degree. Okay. But B joining, okay, C joining with the A and C joining with the E. So angle between these two lines is 100% 90 degree. I think you got a point very, very clear. So if we have a fifth property number 6, we have, if I draw, for example, let's say student, I have one point outside the tangent anywhere. For example, here, anywhere. Okay, I take one point. I take here. Okay, if I draw a two, and I can draw a maximum 2 tangents from one point, not more than that. So for example, this is one point, and just wait a minute, I make it a blue color. This is called tangent number 1. I can draw a second tangent. And I can do maximum 2 tangent, not more than 2. Okay, this is tangent number 2, and you can see here now clearly. So this is point P, this is point A, and this is point B. And for your knowledge, if I join A with B, I'll get 1 minute. I get a triangle, and this is called two sides are 100% equal to each other. And what is the reason of this one? Reason reason. Angle, length of tangents. Tangents from a common point, or length of tangent, we can say also, no problem. Length of tangents. So lengths of tangents from a common point, from a point, you can say even, are equals to each other, are equal, that's it. It means the AP gap, AP length equal to BP length. And I will convince inshallah. And if lengths are equals to each other, common sense, the angles are automatically equal to each other. But I will not leave it, I'll explain it. And look at here, maximum 2 tangents, we can't make 3. Okay, let's come on a point. Show some examples. Some examples, those examples we have a tangent. So look at here, this is a good example we have here. So I think this is a good example to understand. Have a look. This is a tangent number 1. This is a tangent number 2 from A. From A. And this is a confirm that A to D length and A to B length 100% equals to each other. In short story, I can say that I have an isosceles triangle. I have an isosceles triangle in which two sides are equal to each other. If it is 48, so this angle is equal x and this is also x. You can say why x equal to each other, sir? Because the sides are equal and opposite sides, opposite angles equal. In this sense, some of the all angles equal to 180 degree. Some of the all angle equal to 180. So this is a way x plus x, I got 2x. 48 goes on other side and divide by 2. So in this way, I can find unknown angle easily if the two tangents are given from one common point. So have a look now, some more examples, not one example. No, it's a one tangent only. I need two tangents. Is one tangent only? No, I need two tangents. 1 minute,
So
please.
can we draw tangent by ourselves?
No, wait. I don't want to spend time on it. I want to check it. Otherwise, I will make it. No problem. I want to show you the two tangents. There are very less examples available of this category, but anyway, if I make it two tangents, so I think the point is very clear that if I draw two tangents, for example, 1 minute, please,
So
I
can
make
we
it.
make the tangent by ourselves in the exam?
No. In your syllabus, in your this one, we will not make extra tangents. No, in our syllabus, we have one max this. Okay. So, for example, here we have one tangent and second tangent. If I make it from here till here, so you can say that okay, this length, so TP length is equal to TS length because this length and this length equals to each other. So in this way, we can find unknown. So this is 63. If it's 63, 100% is a 63. And if we have a two angles, we can find third on angle. This is a P, for example. P plus 63 equal to 180. Because you know some of the all three angles equal 180. So property, this is also clear. Alhamdulillah Rabbil Alameen. 6 property also clear to you. That lengths of tangents from a common point are equals to each other. So let's talk about some more properties. So next property number 7 I'm going to discuss with you is also one of the most important properties. Okay, this property is also works with a tangent concept. For example, this is a line, is a tangent to the circle, and is a tangent. I'm writing the word tangent here for you. But here now, a 3 point must be on circle circumference. This is called circumference. 3 point. 1 point must be on the tangent point, and 2 can be anywhere, but on the circle, not inside, not outside. Must be circle. So anyway, for example, let's here and 1 point here. So let's A and B and C. I'm going to join them all. Have a look. A, B, this, and the last one here. Okay, so now I made it. This is called a cyclic triangle, not quadrilateral triangle. And hold on. So very interesting part is what? The angle, look, from blue line till this red line, the tangent is equals to not this one, not equal to this angle. Wrong. The other one, this one. It means if this X angle is 100% X, and how to read it? What the reason behind it? Reason. Alternate segment theorem. Alternate segment theorem. That's it. This, if you write this a reason, he will accept it. And hold on. if this are equal to each other, so what angle from this blue line to this one, okay, so equal to naturally this one. And hold on, there's a y, so there's a confirmed y. I think, repeat my words again. If you're not understanding, let's move on some examples, then inshallah I believe you'll understand. Let's start, have some examples. So in this example, yes, we have it. 1 minute please, let me show you. For example, I will erase it first of all. Yeah, it is working here. You can see here some example. Look at here. Can I look at it? This is a triangle. You can see this triangle, and is a tangent. And this angle equal to this angle, confirm. And this angle equals to this angle, confirm. And it's 63 to 63 for sure. I believe you understood this property very clear. Let's have a look some more examples. Not one example. We'll have a look one more. Okay, this is another good example to understand. Have a look here, all of you. If we have a tangent here, but first of all, you keep an eye. This is a tangent, for example. So we need a triangle. Triangle is, we have many triangles. Even, for example, I talk about this triangle. Look at here, look at here, this triangle, this triangle. Let's say if this angle is 60 degree, this 60 degree, 100% this 60 degree. And let's say this angle is 70 degree. 100% is 70 degree. So I hope so. The property is very, very clear. Let's show one more property, one more property.
Yeah, how do we differentiate? Like, how do we?
This is your eyesight. You can, it must catch. Other, with a lot of practice is possible. Less practice not possible. You will not understand that a lot of properties are used at the same time in one question. So your eyesight can catch it only one possibility if you are good in form, good in practice. For example, in this we have a one tangent. We have, you can see, but there are two triangles are connection. How come, sir? Look at here. There's one triangle is here. You can see there's one triangle, and this is a 4x. 100% is a 4x. And this is this angle I don't know, and this angle is actually equal to this angle, but I'm not writing. Okay, let's move on. Another same question, same. And I can tell you another triangle. You can see this another triangle. There's another triangle, and a tangent. So this is a 4x. 100% is a 4x. And this is how much? I don't know how much. This is how much? For example, 10 is a 10. So it means this property is very, very clear, that how it works. I hope so you got a